It's advent of code time, baby, and I am very much enjoying it. So much so that after I finished my own implementation to solve the problems, I still wanted more. Instead of being a sane person and going to HackerRank to do some more different problems, I think it would be way more fun to try and solve the first day of advent of code using AI. And none of that boring ChatGPT stuff. I am going to write code to train the AIs, like a lunatic. The problem we are going to solve is the first part of Advent of Code 2023 Day 1. Because of time, I am not going to read out the entire description, but if you are interested in doing so, Advent of Code is linked in the description. I definitely recommend checking it out. For this problem, we have a file of strings. Each line contains at least one number. Then, for every line, we need to get the first and last number in the line, place these after each other to create a number, and then sum all of these numbers. For this example, it means that we have the numbers 12, 38, 15, and 77. When we add all of these numbers together, we get the final result of 142. For the actual problem, the input is much bigger, with 1,000 lines that need to be processed and summed, as we can see here. With that out of the way, let's get started.
Choose your fighter!
Our first AI is a decision tree, which is exactly what it sounds like. First we check a condition, and based on the results we take a path which leads us to another condition. If we keep doing this, it eventually leads to a leaf which shows us what the actual answer will be. We are going to train all of the different AIs in a supervised way. This means that we need example data and labels that belong to that data. After some quick off-screen data science, I have created a file with input that is very similar to the actual input. I have also used my own implementation to generate the labels that correspond to the generated input. We need to create this extra input for training purposes. If we only train the AI on the actual input, we don't have enough data, and it would be cheating because the AIs would have already seen the input data. The generated lines file consists of 100,000 lines. To create the decision tree, we use one of the greatest Python libraries in existence, scikit-learn. It provides methods for splitting the generated lines into train, validation, and test sets, and it has everything we need to fit a decision tree. With the implementation done, we can fit the decision tree, and we will have finished our first AI. Oh, dang it, that's right. Scikit-learn's decision tree implementation only works for numbers. So we need to translate our strings into numbers. The easiest way to do that is a one-hot encoding. One-hot encodings translate a single character into an array of zeros and 1. Every character has a 1 at a different index. With this method we can translate the strings into sequences of numbers and use these to fit the decision tree. Just translate the entire string before adding them to the dataset and done. Easy. Oops. All of the input also needs to be the same length, so if the length of the string is smaller than 55, we just append a's until the length is 55. Since a is not a number, this should not have any influence on the output. However, fixing this leads to another issue. Using our one-hot encoding method on the data results in 3D arrays, but the decision tree expects 2D arrays. Luckily, this is easily fixable by just reshaping the one-hot encoding arrays using NumPy. Then all we need to do is translate the one-hot encoding outputs back to numbers and done. We have a decision tree. Well, that's unfortunate. It's not very good. While it does get the first digit correct, this is very much not the case for the last one. To try and solve this, we are going to approach the problem a little bit differently. We are going to train 2 decision trees. One for the first digit and one for the last one. And that doesn't improve anything. Great. That means there is only one more thing we can do. Increase the training set. 1 million lines should probably do the trick, right? As we can see, this works much better. Only a few outputs are wrong this time. To check if fitting 2 decision trees is better than just fitting 1, we move all of the code over to a Jupyter notebook. This allows us to only load the dataset once instead of having to redo it every time we want to change some code in the file. This saves me a lot of time since loading the dataset of 1 million lines takes a long time. Well, there isn't a very large difference between the 1 and 2 decision trees. On the first digit the difference is negligible, and on the second one it's only 3%. And at almost 57% for the last digit, I doubt it's going to cut it for the real problem. However, we're gonna try anyway. On the example, the decision trees find 141 as an answer, but the real one is 142. That's pretty close, so it might get the real answer on the actual problem, right? Hopefully? Well, I can't say I'm surprised. For the neural network, I've decided to be a little bit more fancy than just using scikit-learn. Instead, I used PyTorch. Or, more specifically, I used the LSTM implementation from PyTorch. To parse the data files, we just reuse the code from the decision trees. After that, it's just creating our own network. We use an LSTM followed by a simple linear layer to map the hidden layers from the LSTM to the output we need. All we need to do now is click run and we will most definitely have a working implementation. I promise. What? What do you mean an empty parameter list? It is the first input in the optimizer. It says it right there. Neural network dot parameters. What if I just add a list around it? Okay, that didn't work either. Oh my god, there it is. Apparently I cannot spell. I wrote int instead of init. And that did the trick. But now I get a different error. Our batched input is 2D while it should be 3D. But that isn't a problem a little unsqueeze can't fix. Ew, that sounds so much grosser than in my head. Oh my god, it's bad. The printed periods mean that it didn't return any character. Oh yeah, that's right. It's probably never going to return an actual one-hot encoding. Instead, we have to take the argmax and assign the character at that index as the returned character. And now it runs. Let's train it on the 1 million lines instead of just the first 100. Well, apparently 1 million at the same time is a little bit too much. So let's just break it up into 4 batches of 250k. And now, for the moment of truth. Is it going to work? It does, and the accuracy is so much better than the decision tree. This might actually be good enough. Guess what? The answer to the example problem is correct. This is looking very good for us. Dang it. Our last AI we will try is a large language model, or LLM for short. Wait, what's that? What is happening? Okay, fine, I lied. We're using ChatGPT. In my defense, ChatGPT is an LLM and I do not have time or money to train an LLM. The first thing we're trying is if it can figure out how the problem works based on just the example. Well, it's not wrong, but it sure isn't right either. I guess this is why you always have to show your work. Let's try again. Yeah, still wrong. If we paste in the entire problem description, it works, but if we add the problem lines, it gets confused. Very confused. What more do you want from me? You can clearly see a segment of code, and I copied the entire problem. There aren't any more details. The only other thing I have is the problem input. Yes, I literally told you! Solve the problem! I already know that! I want you to do it for me! This is promising. Wait, why did it stop? And where is the sum? That's not the right answer, you just summed the first 50 lines. Well, that's something, I guess, but it's higher than the previous answers from the other AIs, and those answers were too high. Fuck it, I give up. We're just going to let it write some code. And it's wrong. Wonderful. It thinks the file just consists of numbers. Nope, wrong again. Let's try one more time in a new chat. Copy the entire problem again, paste it in, and voila. No, the numbers are not always at the first and last index, you stupid machine. Okay, now it works, but it can't take in a document, so please just rewrite it so we can use a document as input as it says in the problem description. Finally! The right answer. It did it.